In this video, we will cover everything you need to know about significant figures or significant digits. In chemistry, like in other sciences, we use different apparatus to measure different amount of substances. For example, for measuring volumes, we can use burettes or graduated cylinders. Depending on the instrument that we use to measure, we are going to have a different amount of accuracy, and significant digits are going to be different for those numbers that we need to show. In order for understanding how to perform calculations, or many times my students ask me, for example, how many decimals do you want me to show in a calculation, which in reality what they should ask is how many significant digits should I show. But we are going to see the rules of calculating the significant digits and then make some calculations using different numbers with different significant digits, and which are the rules that you need to follow in order to be able to decide how many decimals you need to show in your answer without asking your teacher. So the first thing that we are going to do is to show this example that I have here on the right, and we are going to use that example in order to calculate or to review the rules for significant digits. In here we have 3 leading zeros, and leading zeros are never significant. That means that these 3 leading zeros are not going to be counted as significant digits. Then we have a 3, a 2, and a 5, which are not in these rules, because the numbers or the integers that are different from 0 are always significant. And then we have the zeros in the middle of two different integers from 0, and all the zeros in between non-zero numbers or non-zero integers are always significant. That's why we count them as significant here. The most complicated one for you is the trailing zeros. The trailing zeros are the zeros at the end, okay, of a number, and that is going to depend. They are going to be significant only if there is a decimal point, like in this case. So if we have, for example, a number 300.1, these two zeros are significant. If we have 300, these numbers are not significant. Why they are not significant? Because there is no decimal point. But if I put 3.00, these zeros are significant. They are important, and we need to show them. The last example is when we use exponential notation or a scientific notation. In the scientific notation, you need to remember that we always count, or we always express that as a coefficient, and this coefficient has to begin with a number that is different from 0. Let's say that is 7, and then it's going to have a decimal point, and if doesn't have any other numbers different from 0, we can put the zeros depending on how many decimals we need to show. Why is that? Because the coefficient digits are going to give me the significant digits. In this case, we are going to have 3 significant digits, because that is my coefficient, times 10 to the, let's say, 3. Okay, so this is going to be 7, 0, and 0 are significant. Why? The trailing zeros, or the zeros at the end, are significant because there is a decimal point, which is always the case for an exponential notation, and that is why these are the most the easiest ones to understand. So going back to our example, if we need to calculate the amount of significant digits in this example here, we have a decimal point, so these numbers are significant. These 3 are significant too, and these also are significant because they are in between those numbers. That means that this number has 7 significant digits. The first exercise that we are going to do is going to be calculating the amount of significant digits. This is going to be very simple for you to understand. The first example or the first exercise has 3 significant digits because all the digits are different from 0. In the second one, it has 3 digits. The 0 in the center counts not only because we have the decimal point, but also because we have 2 different digits from 0, so it's going to be again 3. In this case, we have 4 digits, but the ones on the left, the zeros on the left don't count, so we are going to have again 3. In the number 4, we have only 2 significant digits because the zeros on the left don't count, so it's going to be 2. We said that in the exponential notation, we have all the digits are going to be significant in the coefficient, so in this case it's going to be 4. In this case, and this is very important for especially for you, in this case we have only 1 significant digit. There is no decimal point, so the trailing zeros do not count, so this is going to be only 1. And that is very important when we need to round up to 1 or 2 or 3 significant digits and we have only 1 digit. We have to complete that with zeros. In this case, we have a decimal point, so the 0 at the end counts. We have 2. In this one, again, an exponential notation, so it's going to be 4. In this one, the zeros on the left don't count, but this one counts and these 2 also count, so we are going to have 1, 2, 3, 4, and 5, so it's going to be 5 significant digits, and the last one again is 3. Okay, the following examples are going to be for making calculations. When we do a calculation and we put the numbers in the calculator, sometimes we get a number and we don't know how many decimals we should show. In this case, when you do an addition or a subtraction, the amount of significant digits is not going to be as important as the decimals. We are supposed to be adding numbers that have the same unit, like milliliters or grams or so. So that means that we use different equipment to measure the, let's say, the masses or the volume. So we are going to use the one that has less decimals as the leading one. In this case, this one has 2 decimals and this one doesn't have any, so the number that you obtain in the calculator is 19.47, but I should show that as 19 because the answer shouldn't have any decimals because the one of the numbers doesn't have any decimals. Most of the time what I do is, if you don't see it very right away, I put the numbers like in a vertical arrangement, and then I put 7, and here I have 19.47, and automatically what I'm going to do is to cut the number with the amount of less decimals, in this case none of the decimals. So this is going to be the number that we have. Depending if this is less 0 to 4, we leave it like it is. If it's 5 or more, we round it up. The same is going to happen with the next example. In this case, we have 32.56 and 4.9. In this case, we are subtracting these numbers. When we use the calculator is 27.66, but you can see here that I have to chop it with only 1 decimal. Because this is a 6, I need to add up a number here, so my correct answer is going to be 27.7, and with the correct unit, of course. We didn't input any units here. When performing multiplications on divisions, the amount of significant digits will be in the answer will be the same as the number that has less amount of significant digits. In this case, we have 2 numbers here. We have number 1.473 that has 4 significant digits, and 2.6 that has 2 significant digits. So we need to show the answer with 2 significant digits because it's the smallest number. So in this case, we have to get 0.5665, chop it with 2 significant digits, and see which is the last digit or the first digit that we have after we cut the number. So in this case, the answer is going to be 0.57. In this particular case, we have in here 4 significant digits, and in here we have 5 significant digits. Remember that when we have exponential notations, we have always to count the amount of digits in the coefficient. So in here we have 4, and in here we have 5. The problem that when we put the numbers in the calculator, is going to give us 82. So how do we express 82 with 4 significant digits? Well, it's simple. You put 82, and then you have to add up zeros, but you cannot modify the number. It has to represent the number 82. So it's going to be 82.00, and that is going to be the number that you need to show. Okay, this last slide is going to help us understanding or review all the things that we already covered. So we are going to do several calculations. In this case, we have an addition. This one has 2 decimals. This one has 1 decimal. So the answer should have only 1 decimal. So we are going to chop the number here, and we are going to round up or down depending on which is the next digit after we cut the number. So in this case, it's going to be 29.9, but if I add 1 to the 9 on the left, it's going to get to 0. So actually the answer is going to be 30.0. And this is going to be grams, of course. Don't forget the units when you do the calculations. In this particular case, we have 3 decimals here, no decimals here, so the number should show no decimals. That means we need to cut the number after the decimal point. So the number after we cut the in the correct position is a 4, so we don't need to modify the 5 there. So the answer is going to be 15 centimeters. Many times, specifically when you do a titration, sometimes you need to calculate averages. And when we calculate averages, we are going to add all the numbers that we have divided by the amount of measurements, in this case 2. Those numbers that we use do not follow the rules of significant digits. They are supposed to have infinite number of significant digits because the numbers are exact. So in this case, we don't follow the rules of division. We are going to follow the rules only of additions. In this case, this one has 2 decimals and this one has 2 decimals, because in a titration, you are supposed to use a burette, and be careful. You have to always use or show 2 decimals in your measurements, where the last decimal has to be 0 or 5. In this case, it's 0 and 0. And that's why if you add these 2 numbers and divide it by 2, it's going to give you 35.5. We don't need to modify the number because it's already with the correct amount of significant digits. If when you do the average, sometimes you get a third 5, let's say that instead of 50 here is, I don't know, 55. So it gives you another 5 here. Only in the case of the titrations, you can use a third decimal. If not, you should not show it. In the last one, we have the mass of the object and the volume of the object, and we need to calculate the density. So the mass is measured with the triple beam balance, which measure the masses with 2 decimals. But when we use a graduated cylinder, the graduated cylinder show only 1 decimal, and the last decimal was 5. So when we do our division, in this case, we need to count not the decimal, but the significant digits. Here we have 4, here we have 3. So this number should show 3 decimals. So my answer number should cut after the 0, and since this is a 9, I have to add up 1 number here, so it's going to be 1.91. And again, don't forget the units. This is going to be grams over milliliter or centimeter cube, which is equivalent.